All right, I think it's time to get started. Thank you everyone for dialing in and joining Platform 9 for our Kubernetes Fortnight session. That's a regular session we run every 2 weeks. Today, we're actually joined with a partner of ours, NetFoundry, and we're going to have a little bit of an exploration of their platform, which runs on an open source framework called Ziti. And hopefully we're going to dig into some zero trust networking with Ziti and NetFoundry inside of Kubernetes clusters. We will be using Platform 9 managed clusters to demo these capabilities, but this is something that you can work with in any Kubernetes cluster, and hopefully it's some exciting content. On the call today, there's a few different presenters. Myself, Chris Jones, I am a group product manager here at Platform 9. I look after our Kubernetes platform. I'm also joined by Ken, who is a developer advocate at NetFoundry. We've also got a few other people on the phone. I'm going to let them introduce themselves right now, just so you can sort of hear their voices and associate all of us with our particular roles as well. So maybe Clint, if you could introduce yourself, and then Ken and David and Mike.
Sure, sounds good. I'm Clint. I work on that open source project. It's called Ziti. I do some development work, but oftentimes I do engagements like this, talk about what Ziti is, how it can interact with your platform, Platform 9, or in this case, Kubernetes, that sort of stuff. Make some documentation and or demos. And if you go out and check us out on GitHub or Discourse, you'll see my work.
Hi everybody, Ken here, and developer advocate at NetFoundry. And so NetFoundry is enterprise hosting and orchestration of open source Ziti. So I'm focused on making the API easier to use.
Hey, I'm Mike Peterson, technical marketing engineer, and I make videos about our product and Kubernetes and how to deploy different things using PMK.
I'm David. I am a developer relations manager at Platform 9. I like to write code.
Okay, do you want to go over the things we're going to cover today, and then we'll go ahead and get into the demo?
Excellent. We will. Thank you everyone for introducing themselves. We're going to start off with a little bit of an introduction to what Ziti is, so everyone knows what we're talking about. And then we're going to start using Ziti in a hands-on scenario to connect a pod that's running inside of a cluster that essentially has no internet access directly out to a client machine. It's almost like magic, like wizardry. We're also going to look at private cluster communications and management. It's not great to have your API server on the open internet, but quite often that's what happens because securing it can lead to all sorts of management issues. So we're going to look at that as well. And then we're going to touch on a bit of the network policy management that you can start using with Ziti and NetFoundry. And to be very clear, this is not just a Kubernetes specific technology. Ziti is something that you can deploy and build in directly into your applications. It's got a pretty sweet SDK. You can drop it onto your nodes or hosts or bare metal servers into operating systems. So it really is quite dynamic and flexible. So we'll also be getting into a little bit of the policy side of that, which touches on the more expansive use of Ziti as well. So with no further ado, I think we're going to hand it over to Ken, and we're going to jump in. I also would like to say, these sessions we do for everyone that's dialing in. So if you have questions, please ask. We want these to be interactive. So if you're brave, you can raise your hand and we can unmute you. If not, stick with chat or the Q&A sections as well. But really, most importantly, if you have questions about how this can work and how it can help you, this is the time to ask, as we want to make sure that you all get the most value out of this session as possible.
Thanks, Chris. So Ziti is an open source project for delivering applications over a zero trust overlay, an overlay network from process to process. And so that uses an SDK to enable the source code to have this zero trust connectivity. And this is ziti.dev on the web. And so that's the place to find the SDKs and play with the different examples and get help. The best place to click through, and we'll cover this again at the end, it would be the support tab to get over to our discourse forum. That's where you can find the maintainers and access them directly. So good presence there on Discourse and GitHub. And so how can you use Ziti? You can use Ziti to connect pretty much anything over dedicated overlay. And when you build on an overlay, you don't have to worry so much about the links between the pieces of your application stack, because they're going to be encrypted, and they're also going to solve their own connectivity problems, adapting to things like internet conditions and simplifying the edge. So we're going to bring up a high-level diagram here of applying Ziti to Kubernetes. The basic idea here is going to be to install Ziti in the cluster as a pod, and that'll be able to serve up whatever else is running inside the cluster, including the Kubernetes API server itself. So here's a high-level diagram of Ziti. We've got 3 rectangles here, and over on the left, we're seeing some users or data centers, sort of like your endpoints, your edge. Then there's the Ziti fabric in the middle, which is a mesh topology and adaptive with smart routing, going around internet congestion problems and finding the best route to things. It's also highly customizable and programmable, and that can be self-hosted or hosted by NetFoundry. And then there's our cluster itself inside an AWS VPC. So we're going to start out using the load balancer to get to our cluster, and then we're going to connect directly with Ziti, bypassing the load balancer.
Ken, if you don't mind, I'll hop in here real quick too, because
Yeah, do it.
one of the things I heard, I think it was David say, was that Ziti's seems like magic. Or maybe it was Chris, I think, said it. Ziti's kind of like magic, and it's really not magic, right? It is exactly as demonstrated right here. The real key is this Ziti fabric, and you can see from the arrows, you can see that on the right-hand side, the hosting pod is reaching out through the internet into that Ziti fabric, using a strong identity that's configured on that hosting pod. So mutual TLS, established connections, that's where the security comes. That's where that lock icon comes from. On the left, you can see the same thing. You have users, you have other routers, whatever, also reaching out into that topology, into that Ziti fabric to create that secure mesh overlay. So it does feel like magic when you deploy this and everything just works. And hopefully, I'm sure it will work today. And live demos, you never know, but I'm sure it will. But it does feel like magic. It's not magic. That is exactly how it works. So you do need a piece of hardware somewhere that is a rendezvous point, making that Ziti fabric for you, and everything else is handled by that magic. And it is pretty cool when you see it work. Just wanted to give that extra context, Ken.
Yeah, so that's a little bit about what Ziti is, but as soon as the questions stop flowing, I'm going to jump right into installing some Ziti in this cluster, as well as some toy apps, so we have something to use over Ziti. Let's take a quick look at our Platform 9 console first, just so we can get a quick overview of what's running out here. So we've got one cluster, and it has just 2 nodes. Everything looks healthy. Got a master and a worker. And I have clicked on the kubeconfig button here to download that. So we'll be using that standard kubeconfig from the PMK console here to get started using the cluster. So I've got that file downloaded in on my computer here and set as kubeconfig so that I can access the cluster with that authorization. And let me know if my terminal's not legible. I can make the text larger if needed.
I think it looks good, Ken.
All right.
And we got a question that came in too.
Sure.
Say, hi, does it mean that in the Kubernetes cluster, the ZD edge can only sit at a pod level, or is it possible to have ZD client for a node, or even have a ZD client at for each container inside the pod?
Actually, yes, there are several different ways to apply ZD in Kubernetes. And those would be as a sidecar or as a daemon set, enabling the all the pods scheduled on a particular node for bidirectional communication with ZD. The sidecar would be bidirectional for a particular pod, and then the one that's the one that I'm showing today is the hosting pod. So that's just a Helm chart, Helm install ZD, where the pod is just hosting. So the arrow is going out from the pod to other pods.
And when we mean hosting, we mean providing ingress to that Kubernetes cluster.
Right, one directional, not providing the egress exactly from, like if we're providing basically this is an ingress solution for this PostgreSQL pod. And if we want to publish that or expose that over ZD, it can be a little difficult to expose workloads in a Kubernetes cluster, and so this is a very flexible, very secure way of doing that. Your typical alternatives are things like load balancers and node IPs and ingress controllers, and those certainly have their place, but sometimes you want to expose a service privately or under very strict conditions. And so that's one of the things we'll be demonstrating here. Does that part make sense?
I think that's a good question. It's definitely something that comes up a lot, is exactly how to provide that sort of ingress to other workloads.
Right, so for this example, I'll be focusing on exposing a service using ZD. That is a cluster service running in the Platform 9 Kubernetes cluster. I'll be basically publishing that or exposing that in a controlled way. Right.
So follow up. So they're saying, in other words, we can use ZD to connect pods in a cluster or unit workloads between each other.
That is also a possibility, yes. And we can do that. I think it's a little simpler to start with the one directional case, and then we can add the bidirectional case onto that if we still have time and interest. But that, for example, if you were doing that, you might have two different clusters, which I have a different drawing here showing two clusters. And so if this is the one that we set up on Platform 9 and AWS down here, then you could have like a sidecar right here in a different cloud that was enabling bidirectional. So that pod would be able to access whatever you'd exposed over ZD.
And you could also build this directly into the applications, right, using the SDK?
That's correct. These different levels of applying ZD that I've mentioned so far were using the agent method, but agentless is far superior if you think about the fact that you eliminate the additional variables of DNS and IP ranges like static routes, and all the traditional networking concepts sort of evaporate if you're going agentless, that is using the ZD SDK inside your app. Then it has its own identity and its own networking configuration right there inside the process, and it doesn't need any of that accompanying ZD orchestration.
Yeah, there's a clarifying question that came in here. Can we achieve the same thing, meaning pod-to-pod connectivity with Calico? Yeah, I think this is a good point, right? So Calico is your container networking layer, So when you build a Kubernetes cluster, you need to put a networking function in, and that's what allows all your pods, services, deployments to talk to each other. That's what provides your services CIDR range, your pod networking. So this is something that is supplemental to that base layer. So Calico will still work. Everything can still talk to each other. You could, if you're using BGP, encrypt your traffic and then use BGP with route reflectors and external route reflectors and have communication between two Kubernetes clusters with pod to pod. Yes. If you don't want to go over BGP and the open internet, or you don't want to have to go and invest in creating your own private BGP network within, internet frameworks, Ziti would greatly simplify that.
Yeah, can I add one, I think, even more powerful reason that Ziti is superior in this case? I heard two things in there, CIDR range, and I heard BGP network. With Ziti, you're creating a secure overlay. And because of that, communication is only allowed to happen amongst the services which you have authorized. No additional ports are allowed. It's giving you the capability of not being susceptible to side channel type attacks where you have, say a CIDR range that's open. You can only attach to the service that you are supposed to be attached to. And we also authenticate you before even network traffic is allowed. So because of that strong identity, you can't even get at the network. You can't even make a request without presenting that strong identity and becoming authorized first.
And I would say it's significant, like Chris was suggesting, that it's supplemental. I would add interoperable is an important descriptor there when we're talking about things like eBPF with Cilium or IP tables and ubiquitous container networking, like a CNI approaches to Kubernetes networking, where yes, you can potentially span the same logical network and the same network policies across clusters, and that's perfect for Kubernetes, but other things need to connect in some cases, like maybe your mobile devices or IoT devices in a warehouse, or your data centers or your users. Ziti is ubiquitous in that it really is superior in its reach, its ability to work with any OS, any device, and so that's where it comes in handy.
I like the questions.
So I'll show you what we've got right now. I'm going to start interfacing with the Kubernetes cluster. We'll answer questions as they come in. That's perfectly fine. So I've got my default context in the kubeconfig that I downloaded from PMK. And that is using, let's find we want to just take a moment to dwell on the configuration that we're actually using here so that we can be very intentional about showing what changes, what's different. See, I've got a cluster and a context commented out there. We'll get back to those in a minute. But we're going to be switching over to those after this is set up. So I'm going to run an SSL command here, OpenSSL, against this load balancer. This is the elastic load balancer that was created by PMK. When I created the cluster, I plugged in my AWS key and it created the cluster for me, and this is the load balancer. I chose not to use a Route 53 zone. That was one of the options when I used the create wizard for AWS. So this shows us the subject alternative names for the certificate. And that's just to illustrate what we're connecting to. In AWS, it's a raw TCP load balancer, just passing the traffic straight through to the master API server. And that's the certificate that's bound there. Did I get that right, Chris? That was my summation of how everything was mapped.
That is correct.
Cool. All right. So that's what we're connecting to in the default configuration. And we want to go ahead and install a few things in the cluster. So let's see. I'll switch this over to my deployments so we can see those appear as they get installed. I'm going to install this HTTP bin from the Istio project. It'll give us a simple REST test server. And with that, if we take a look at our services that are created, so now we have an HTTP bin in the default namespace listening on port 8000. That'll be useful. And now I'm going to also install another little. Well, let's focus on that one first. So what I want to do is enable access to this service inside the cluster. And so I'm going to install Ziti. So in order to obtain an identity that I'll use to install Ziti inside the cluster, I'm going to switch over to the NetFoundry web console, which orchestrates my Ziti network. Now the Ziti network is already running. I used it for the practice session, but I've gone ahead and removed the pieces that we're going to need. Most of the pieces that we're going to need. So the first thing I'm going to do is I need to mint an identity. I need to create an endpoint that'll have a Ziti identity associated. Just going to call this, give it a name, give it some attributes. So we're using role-based access control. Sorry, attribute-based access control in contrast to role-based access control here. And that means that you can label things just like hashtags and use that to create policies. So don't anybody steal my key before I get to use it here, but I'm going to download that file so that I can reference it in a moment. If I was enrolling a mobile device, then I might scan that QR code in order to grab that identity. Go ahead, Clint.
Yeah, I was just saying, this is that secure identity I was talking about before. So Ken, you go ahead and continue, Ken. Ken has downloaded that JWT file, which he's going to use to enroll his endpoint. And the active enrollment is interesting because that's where you will generate a private key, and that private key will then never leave your pod or your endpoint or whatever, however you end up registering that endpoint. That's the key. That whole process is what we call enrollment, and it's really important that private key that gets generated not be transmitted around. Every identity, every connection should have its own identity. So the chart that he's going to install is going to consume this token.
So I'm not going to press enter yet. We can talk about the stuff going on here with this command. Make sure this is clear, so it doesn't. I do want to vanquish any sense of magic, right? So let me know if this doesn't make perfect sense. What am I doing here? Got a helm install command. Go ahead.
No, I think we're good.
All right, cool. Just going to define a variable and another variable. And the reason I'm using the full name override is because that variable gets used for the storage class. And it just takes, if you reuse the same one, it takes a long time for EBS to cycle through and release it. So I'll just create another one. That's something I didn't show, but you probably guessed in my PMK cluster, I went and created a default storage class for GP2 on EBS. So it's using that for the PVC. Persistent volume claim for this chart. So what it's gonna do is it's gonna take that JWT, which is in a single use enrollment token, and it's going to shove that into a secret that gets mounted on the container, and it'll use that when it starts up its entry point script will perform the cryptographic enrollment, and that'll generate a permanent identity for that Ziti agent. I guess it still had some artifact in there. So I just noticed that if I do a Helm uninstall through K9S, this little terminal GUI that I'm using, it doesn't actually fully uninstall it. One little got you there. All right, looks like that's starting up. Now it doesn't have any workloads assigned yet. Nothing's been exposed, but it does have an identity, and that's been written to the PVC. So we are good to start assigning stuff to that endpoint. And now we see we have the pod there, and that is the Ziti center of our cluster universe, onto which we can now attach workloads or services in the lingo. So let's do that. Over here in services on the sidebar, we don't have any yet. So let's start out with a simple service for that HTTP bin cluster workload. We're just going to expose that as a quick test here. So we'll call that our REST test server. I'm going to give that an attribute also because we have a policy that allows my client on my computer to talk to green services. So this is going to be the domain name that's used to access the service. And we're going to now assign it to that.
That's not a DNS entry put in somewhere. That's actually something that the ZD project provides for you. So that DNS name that he typed in can be whatever you want. You notice that's not even that's not even a valid top level domain. But the ZD endpoint that Ken had mentioned before, he said his endpoint is authorized to talk to green services. It'll be able to use that host name that he's typing in here.
That's correct. And we know our cluster service is listening on port 8000. The cluster service name is HTTP bin. It's in the default namespace and it's a service. So using Kubernetes conventions, we can access that service or anything that's accessible to the namespace where we installed Ziti. We can expose it in this way.
I think that's a pretty cool feature right there, right? The fact it's sort of saying Ziti's in this particular namespace, so it's living with Kubernetes constructs, which helps make it secure. And then it's saying for this service that's also sitting next to it, called HTTP bin, we're going to connect that together.
Right. And I'll flip back now to the Kubernetes view here, so we can just refresh our memory. We're going to be connecting to this service, HTTP bin, on port 8000.
With no external IP.
Correct. It has an internal cluster IP, but we're actually going to connect to it in a moment here with this domain name, this fictitious domain name. Or if you want to just invent one, let's use that, lavender alpaca. That'll be our domain name for this service. So it just has to be a valid DNS, valid domain name. It doesn't have to be a real domain name. See what I mean?
Good choice of name.
All right, so that's been assigned to that exit identity that we minted just moments ago. And actually, we can do a little sneak peek here of the pod itself. If we flip back over there and look, we should see evidence that it's received that instruction. There's REST test 2 came in. So hopefully that's functioning. We'll find out in a minute. So I've got my, in the top pane here, pane number 1, I've got another Ziti client running. That's basically just, it's an agent to enable my workstation here to use the Ziti network. And what does that look like inside here? Because it's all being orchestrated through this dashboard, right? So that's me, that's Ken, client 16A, and I'm a green endpoint. And then there's this policy up here that allows me to talk to green services. So that's what's connecting me over to that REST test server. Hopefully that's filling all the blanks. I don't want to go too fast, but I have, so everything should be aligned. I should actually be able to get to it now. So I'm just going to run, I'll go ahead and show you how my workstation has been configured for this, by this agent. So if I ask my systemd, I'm running Linux here, and if I ask systemd, you know, what is your current resolver configuration, I can see I've got a ton device with a 100.65 address. So if I do a dig at that IP address for lavender alpaca, it's not come through. Did I misspell it? Lavender. Oh, there we go. We do have an IP. Ah, saved the day. All right, so yeah, it's great when it's my part. When I'm, the problem exists between keyboard and chair. That's all you have to remember. All right, so let's compose a request here. I'll use HTTP. We could use curl just the same, lavender alpaca /IP, because we're talking to HTTP bin, and it has a little /IP endpoint, which will echo back to the requester the IP that it saw that request originate from. See if we get anything here. No, we actually got an error. So Clint, let me know if you see what I've done wrong.
Could you go back and see the service policy for the router? Like I saw a few of those no edge router errors fly by. Did you see those?
No edge routers assigned and online. Oh, I see it. Yeah.
Back in
It's
the
saying it
back
failed
in
to
the,
bind to the service because it doesn't have any edge routers.
back in the NetFoundry console, can you just take a peek at the edge router policy?
Yeah, sure thing. So we've got red endpoints to red routers, green endpoints to green routers.
And the green routers are public and the red routers are private. Like, shouldn't the new endpoint, the exit 16, have access to one of the routers, or are they both public?
All the routers are public.
Yeah. Well, that's fun.
Oh, here's what I did wrong. I put red routers instead of red endpoints in here.
Aha.
I got confused. I was trying to be clever by using unambiguous labels, but I don't have as much practice with that. I had been using just green and red
Yep.
for everything.
Good catch.
So hopefully that
Now
takes
you
care
should be
of
able
it.
to, yeah.
I know it's on a service polling interval of like 15 seconds. Yep, there's all the no edge routers errors from before. If we get impatient, we could go ahead and just clobber that container and let it reschedule.
Yeah, I mean, I would have thought for sure that it would have come through already.
All right, I'm gonna do a delete on the hosting pod, so it'll recreate it. We'll see if the new one has everything it needs, in case it's some kind of delay with it getting the new instructions.
I mean, it could be a bug too.
Once we get through this, we're going to look at updating a kubeconfig file and then using Ziti for API server access, right?
Exactly. Yeah.
That's right. So we just got the success we were looking for. See the IP that came back from the HTTP bin echo service?
Origin.
Yeah, I just had to bounce that hosting container for some reason. So, and to illustrate the significance of that IP address, we can look at our nodes here and see the node IP for the worker. Is that I mean actually the pod is should be the pods in the default namespace. Yep, the pod IP right there is the match 6.64. So the HTTP bin service here responded with an echo saying, I got a request from this IP, just to illustrate how they're related.
That's pretty cool.
See that? All right, so now let's apply the same concept to the API server itself. And that's the sauce right there, because we want to be able to bring our cluster completely dark, not exposed to the internet, and that's where we're going here. So all that we need to do is add another workload in services. Let's just describe the API server this time. We'll just follow the same pattern, green service, and but this time let's use one of the SANs that are.
This is important.
So because we're using TLS over Ziti, we're going to use one of the subject alternative names that is verifiable from our certificate here. Instead of making up our own lavender alpaca name, we'll just use this guy.
Yeah,
So,
and we can't because the TLS connection, like Ken was saying, would not be valid. The certificate that's presented uses one of these SANs, like he was talking about. So it absolutely has to be one of those. But you'll also notice, I'm sure Ken's going to pick one that is clearly not an actual top-level domain, like Kubernetes
exactly. So
default service.
we're getting NX domain right now for this domain name. It doesn't exist in recursive DNS, like global DNS. You don't get an answer for that name. So that's a good candidate. We'll just paste that in there. I forgot my K. And we'll use 443. Now let's double check our cluster service details in Kubernetes. In the default namespace, we have 443 as our port, and the name is kubernetes.default.svc. We'll, just like we did last time, we'll assign it to that same endpoint. 443. Look good?
Yep.
All right.
Sounds like something is bothering your dogs too, Ken.
Yeah, I wondered if you could hear that.
It could be me with my airplanes.
So now, are you just waiting for the poll interval?
Yep. So I'm going to try that same command that I tried a moment ago to look up the domain name, kubernetes.default.svc. Same pattern as before, cluster service name. And I'm pretty sure that's a Kubernetes default, that it always provides a Kubernetes domain name for the API server.
I did this with Minikube just yesterday, and it sure seems to be consistent.
Yeah. So we did get an IP address back now that tells me that my agent has synchronized, and now I can, quote, see that service. So I'm going to just see if I can get a certificate back. I'm going to run that my OpenSSL connect command again against this domain name, which is now being provided by Ziti on this computer. Let's see if I get anything. So we're getting the same certificate back because we're connecting to the same API server on the master. We're just doing it via Ziti now instead of over the internet through the Elastic Load Balancer.
We got a quick question that came in, Ken, asking
Yep.
what does Ziti use to build a link between the remote user and the cloud-based workload? It is mutual TLS. It is not a WireGuard tunnel. So the identity that Ken showed before, where he downloaded the JWT file and fed it into the Helm chart, that creates a certificate that is signed by the Ziti controller. Once that Ziti controller signs a certificate, the CSR, that certificate is then presented back by the Ziti software. So that's what the active enrollment is. So it's not WireGuard, it is mutual TLS.
Right. Yep. Every Ziti identity is a certificate issued by the Ziti's built-in certificate authority. It's just standard PKI in that sense. X509 certificates everywhere, and mutual TLS. So the client authenticates the server authenticates the client before the data starts flowing.
All the pieces of the network have to do that. That's what when I was saying before, you can't even get on our network without presenting a valid certificate. And I will go one step further than that too, which was, I just forgot because I just started saying all those things. Well, if I come up with it, I'll remember. I'll follow up. I forgot what I was going to say.
I'm going to open my kubeconfig now and uncomment these things so that we have an additional server, an additional context.
I remember, Ken. One thing I wanted to add is it doesn't have to be signed by Ziti. Ziti, the open source software, also supports your own PKI. So if you want to create your own certificates using your own PKI, you can upload your third-party certificate into the Ziti controller and use your own PKI. You don't have to use what Ziti provides for you. It's just easier for most people.
Oh,
and then
right,
also,
because I said the built-in CA. Yeah, that's true.
And then also we do support hardware tokens too. So if you have, say, a YubiKey on your local machine and you wanted to enroll that, you can go down that route too and go all the way to a piece of hardware.
All right, so I'm going to exit out of K9S and restart it so that I can reread the kube config. And now we can see we do have an additional kube config context for Ziti. I'm going to switch over to that one. And it looks like we're good. So now we are looking at the cluster through Ziti, and there shouldn't even be any communication between my computer and that load balancer. So that load balancer is still available. Actually, we could check for that, couldn't we? We do a
If you went in to AWS and just wiped out that load balancer altogether.
I did try that, but I found that it upset PMK because I think there's a management routine going on there.
The bring it back.
Yeah, like it rolled some aspect of it. It caused it to assume an unhealthy status.
Yeah, it's how it's how the control plane nodes and etcd and all the applications are running. So, I mean, the other way of doing it would be changing the VPC configuration. But once we've built that cluster, if it's on a public-private VPC, we're also managing that state. So it's finding with our our way of building and managing the cluster because we're managing it for you. So if you take an action outside of platform 9, it's going to kill it.
Right.
And take it back to the state that you said it should be in. If you built a completely private cluster, then you could essentially use this method to tunnel in.
Right. So doing a packet capture now for that ELB on port 443. So I thought I would just switch my context back to default to see the traffic start flowing there.
Oh, instant.
Instantaneous, yep.
So now, once you get to a good place here, would you mind, Ken, just kind of do a recap on the setup that you've got going right now versus what a typical cluster connection might be?
Yep. So right now our switcher is the kubeconfig context. The default one is what was downloaded from the PMK console, and that has this Elastic Load Balancer domain name in it as the server URL. And that lets us connect over the internet with our token, our exploding token from PMK until that expires. And so I created an additional context, which just has a different server URL. And that additional server URL is the Ziti URL that we configured in the
Private
API
URL.
server service right here. That part that I just highlighted.
All right, so we're going from your machine to NetFoundry Cloud. Sorry if I don't know the proper name there. And then from the NetFoundry Cloud to the cluster. Is that right?
Yep. That's exactly what happens. So on Ken's local machine, he has that DNS server that knows how to resolve the Kubernetes default.svc URL, so that when he uses kubectl, he can just type kubectl get pods or whatever, and that will do exactly what you said. It'll onboard into the Ziti fabric, travel over into the pod that he installed inside of Kubernetes, and then offload onto the actual Kubernetes service, or to that toy that he installed, the HTTP reflector, HTTP bin, or whatever you have, Postgres, whatever. You know, he showed that diagram before. We had a whole bunch of different workloads exposed. Anything addressable by the pod would be addressable privately through Ziti.
Yeah, you know, something that just occurred to me. I'm sorry, I'm going to share this publicly. You know, I something in another project that I'm working with is we have obviously a database running, right? We have our apps running and then a database behind that. It's all in the same cluster. The thing is, we want to lock the database down. We only want it to be accessible within the cluster. But the challenge is debugging, right? Because the developers, us, need to be able to get in and see things. But it's achieving that balance between the two. And this is really showing a nice way of, I could just open up, you know, a Ziti managed connection to my databases. So as a developer, I could still get to it, but be super validated. But they're still not open to the public. I can get in and do select statements on them. And then the apps, those have the ingress, those have the public access.
Yeah, absolutely true. Yeah, totally. And in fact, one more thing that might blow your mind a little bit, which is I just did a video showing private Postgres database from my application not too long ago. I could share it, but it's all Docker based, it's not Platform 9 based. But we are also building a ZDBC, which is basically a wrapper around JDBC that allows you to use a driver in your local dev environment that would not require that little agent that Ken had to install. So that way, you know, now you're actually, we call that Zetifying something. So we've Zetified Postgres.
Cool.
Yeah, it's super neat.
that's
So
cool.
you can use Squirrel, or you can use data grip from JetBrains. You add the same driver that you would add normally, Oracle, Postgres, whatever it is, and then you just connect without even needing that agent locally.
And you guys are looking at doing the same thing with kubectl, right?
Yeah, in fact, I was just playing with that yesterday. So I run local Minikube, and I did exactly this demo with Ken last night using Ziti to mine Minikube from his computer down in South Carolina to mine up here in New York, which is really cool. So I exposed my Minikube on my virtual machine in my Docker network to Ken, using that same Helm chart that he just showed you, using Kubernetes and Minikube and all that. And he was able to use kubectl.
That's pretty cool. I mean, in terms of simplifying a workflow for developers, you would just be issuing that out as the binary, right?
Yeah, you can actually download it right now if you're adventurous. You can go out and find it on OpenZD Incubator, kubectl. It's under GitHub. And it does work, and we're working on it, making it a little bit better still. So yeah, it's out there right now.
That's pretty cool.
I went ahead and installed another pod in the cluster, Hello ZD, on port 80, and I assigned that one as well to the same hosting pod, same ZD pod in the cluster. And I gave it a fictitious domain name of hello.zd and brought that up here just to show, no matter where the server is running, it's using ZD, then you can get to it.
Cool. We do have one more question here from a person. What does the NetFoundry entity do for the connectivity to be built? So I assume what he's saying here is the NetFoundry entity would be the local tunneler. So we have these things we call, can you bring up the diagram one more time, Ken?
Yeah, sure.
So we have these things we call the agent that runs locally. We call them tunneling applications. And so what happens here is Ken makes an HTTP request to Kubernetes.default.service. That HTTP request goes to a locally running DNS server that is provided by that tunneler application. There's one for Windows, there's one for Mac, there's one for Linux. As you can see, obviously Ken's using Linux. So that tunneler takes and returns the IP, the private IP that's scoped just to your computer that is for that service. And then your computer sends regular traffic into its operating system, which is picked up by that ton. That ton is then sent through the ZD platform or the ZD local software, which puts it onto the ZD network. We have a whole mesh topology that is knitted together. There's a whole bunch of other componentry that does that, where we've created a whole mesh overlay for resiliency, performance, lots of reasons. And then it does all the exact same stuff on the other side in the Kubernetes space here inside of Platform 9. It would get into that pod, and then that pod, because it's running a special tunneler app on its side, that's the Helm chart that Ken went through and installed. It knows how to basically offload that traffic. So what's really cool is we only need the internet. I mentioned this before. Another person asked about Calico and Flannel. We only use the internet. We don't expose CIDR blocks. We can, although I personally discourage it because I find it goes against the ethos of zero trust. And here at NetFoundry, we're all about zero trust. But I also recognize that it's oftentimes a journey. So lots of customers will start off by installing these tunneling applications that you've seen, we talked about right there, and then migrate slowly into actually taking that SDK that Chris had mentioned a couple times, stuffing it actually into your application itself. And now you have what I call a Z-defined application. kubectl is one of the ones that we've taken our Go SDK, added it into kubectl, and then we use the tunneler on the other side to send that traffic over to the private API space. So it's very cool stuff.
Here I was just showing what it looks like to run the tunneler on my computer.
Yeah, I appreciated that,
what-
Ken. I saw you following along. That was great.
Okay. There's a correlation there between the IP range that I've specified for ZD on my computer and the IP routes. And since it's not running right now, I don't have a route for like that. Don't have one that matches the 165 range, but as soon as it is running, then I have that route to that device, that TUN0 device, and I also have a DNS resolver that will give me back an interception IP for any ZD domain names that I'm allowed to talk to. So that's just what it looks like enabling ZD on this device, on my Linux device. Like Clint said, we have the ZD Edge for all the operating systems, Android, iOS, Windows, and Mac OS.
Oh yeah, don't forget mobile. Mobile's important too. That's a big space.
Yeah, I think the cool, like Ken and I connected a month or so ago, and we went through this, and I installed it on my Mac, and I was like, wow, this is like instant. And we just started adding routes for all sorts of services that were running in my Kubernetes cluster, and it connected it. And I then sort of took a step back and looked at the entire platform. I was like, well, wait a second, you can do this point to point from people's mobile devices. That's a pretty strong set of features that you can deliver to your end users, your customers, anything really.
Yeah, and there's actually, like, we only touched on the surface here. There's a whole bunch of other stuff that ZD can do for you that's really cool. So Ken had used, I don't know if you remember, but Ken had used the red endpoints attribute. So we have attribute-based access control. There are continual authentications that can be done. So we have these things we call posture checks. So like you have to pass a posture check in order to be able to access the system still. The typical MFA type, all kinds of other stuff like that. One question came in about ZD in Java apps. Yes, there is examples. The best place to find those, I can go and get that URL real quick and toss that into the chat. But if you go out, if you just go out to GitHub and you go to the OpenZD project itself, oh, look at that. Ken's already on the screen, SDK JVM. Thanks, Ken. In the samples page there is where you'll find the JRE actually. Right?
Yeah, I went to ZD.dev and clicked right here on the Java tile.
Oh, that's even easier. That's a great way to get there too. But in the samples directory, you'll find the exact one that I talked about with Postgres, the one I recently did, like a month ago. And other ones, HTTP servers and whatever.
Yes, so we're definitely expanding. We're rapidly cracking open all kinds of different projects to try to demonstrate ZD. We're really interested in ideas that, if you've got them, for how we could use this novel use cases or just to make pain go away.
It says, other than instrumenting the Java apps, what components need to be installed in my networks? Depends on what you wanted to access, but if you wanted to access something presumably in your Platform 9 Kubernetes cluster, you just have to install that Helm chart. And then to go back, thank you, Ken, you need that ZD fabric. So you need to have at least one public router. You can host it your own out on that GitHub site. You'll find a aws.markdown. Can you bring up the aws.markdown real quick, Ken? Do you know where that is? Just, I think if you type AWSMD in Google for it, it'll find it. But you need that one public router. You can host it yourself if you like, or you can go to NetFoundry and sign up for a trial and try it and see all the stuff that Ken has shown you here. You'll see the same console that Ken just did and use the same sort of stuff.
Sorry, I'm not sure what AWSMD is.
Quick start. Oh, actually, under doc, I think. That's under doc. No, I don't remember. I'll find it. You got 1 second.
Well, this is the ZD fabric that Clint was just mentioning. It's a click to install, we'll click to create. So Ken test router.
Yeah, and this is the public. This is that public router that we're talking about. This is what you need in order to create that rendezvous point. This is the quote unquote magic, really, where the two sides can make an outbound connection to that router. You can definitely use your Cisco routers, sure. It gets a bit more complicated when you start doing that sort of stuff. And as long as you're, as long as you understand what ZD is doing and how it's doing it, you can certainly interact with them. But it gets much more complex when you start trying to build your own routes and whatnot using routers. But if you know how to do that, sure.
Well, I don't fully understand the question about Cisco routers, but I'm guessing that you would want to maybe run ZD on the Cisco router. I guess that depends on the CPU architecture. Thanks for clarifying that. And so if it's, I don't know if they're, what is the
we have a open
PowerPC or x86 or MIPS CPU architecture, but we do have very good reach as far as CPU architectures. I've personally seen it run on MIPS, ARM, x86, and I'm trying to remember if we had at least one build on PowerPC, I believe. So we just need to establish that you're able to load up a binary that's compiled for that CPU architecture.
Yeah, the real question is if you have access to it and can install something on it and you can compile it for your architecture. So the ZD Edge tunnel that we have is C-based. So as long as you're able to compile that, then you would be able to access that and use it. The ZD Edge tunnel is that it's a C-based version of that Edge client that we keep talking about. I think the Helm chart uses this, right, Ken?
The ZD host Helm chart is using the Go-based hosting tunneler for the single direction use case.
Gotcha.
But here's the tunneler SDK.
You use this locally, correct?
That's right. I'm using the x86 build of this binary right here for today's demonstration to enable my workstation in this top pane here, which I'll expand when I'm running sudo ZD Edge tunnel. I'm running that C-based tunneler SDK. Yep, you can enroll a Windows endpoint. I don't have a Windows
using it right
computer.
now. I could show you if you wanted to, but yeah, there's a ZD Desktop Edge for Windows, and you also could use each operating system gets a little bit finicky, so it probably is best to use the ZD Desktop Edge for Windows. Each OS does things a little differently. So the Mac one doesn't quite work quite the same as the Linux one, quite the same as the Windows one. But yep, all major OS.
They do look very similar though, and they operate as far as the user experience, they're pretty much identical. But I went to zd.dev and clicked on Windows to get over to the Windows Edge agent client.
Cool. This has been a good session. I was excited to get this up and get a demo going. So thank you very much, Ken and Clint, for your time.
Absolutely,
hopefully
my pleasure.
Attendees found this useful and hopefully inspiring. I sort of saw the technology and I was like, people can use this for all sorts of fun, crazy things. So hopefully we've inspired.
It's been great.
And there's a few questions about recordings. Yes, we record these and we publish them on YouTube in all of their unedited glory. It's amazing. So if you do want to jump back in or share it with friends and colleagues, it'll be up on the Platform 9 YouTube. We can also share it with the Ziti NetFoundry guys, and they can post it as well. So it'll be available on both. If you have questions, please jump into the ZD discourse or Platform 9 Slack at slack.platform9.io. Always here to help about questions on how to get Kubernetes going. Unfortunately, if you start asking us around ZD, I'm going to have to grab the guys from NetFoundry, but they're in Platform 9 Slack and really accessible. So
yeah, hit us up on that Slack for sure.
All right. If there's no other questions, guys, I think it's time to wrap. And we have another session in 2 weeks. I believe it is on Kubernetes networking. We're going to be getting into a little bit of the EBBF, too many acronyms for me, chats. And I think we're getting the team from Calico online. So that one should be really fun as well.
Good
with that.
stuff. Thank you, Chris.
Sounds good.
No worries. Thanks
See everybody
again,
in 2 weeks.
everybody, and see you all. Yeah, 2 weeks.
Cheers.